Hello friends, this video on application of derivatives part 11 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 10. Let's look at the new topic called tangents and normal. Here we will learn how can we use derivative to find tangent or normal for a particular curve at a given point of time. At a given point actually. So in this case, we'll learn use of differentiation to find equation of tangent and normal to a curve at a given point. Please note, at a given point is critical because we have to find these things at a given point. So equation of a line passing through point x0 y0 and x0 y0 and with the slope m is this. We know this. This is a prerequisite. You should know this, that equation of a line which passes through x0 y0 and has slope m is y minus y0 is equal to m into x minus x0. I'll tell you how. For example, this is a line. I know x0 y0 as a point. This I know. Let xy be any point, and this is the slope is m. Then we can say that slope is nothing but y minus y0 by x minus x0. Correct? And this is what you get. Y minus y0 is equal to m into x minus x0 is the equation of a straight line with points x0 y0 and slope m. Now if you want to find the tangent to the curve y is equal to fx, the first thing I have to find is slope. Why? Because my equation has nothing but 2 points and a slope. So if I can find the slope and 2 points, I can find the equation of tangent. Correct? When I'm talking about fixed points, I know the fixed points also. When I'm telling that I want to find tangent to this curve at these points x0, y0, I have these points. The only thing is I want to find the slope. So let's find the slope. Slope is defined as nothing but if you have this, let's suppose some curve, at this point you want to find slope. Slope is nothing but you find the derivative of this function at this point. So if you see slope of tangent, please note slope of tangent is nothing but f dash x0, because at this point x0, this point is nothing but x0 y0. At this point x0, you just find the derivative, and that becomes the slope of the tangent. Correct? If I have curve like this, this is my tangent, and the slope of the tangent is nothing but f dash x0. Now if I have the slope, I can just choose this equation y minus y0 is equal to m. Instead of m, I am putting f dash x0 into x minus x0. This is nothing but equation of tangent. So with this, I have, for a given curve, I can find the slope of tangent, that is nothing but f dash x0, where x0 is the point where we want to find the slope. Because if you see, if I have my curve like this, let's suppose curve like this, let's suppose this is a curve. At this point the slope is this, at this point slope is this. So if you see, the slope varies based on the point. For a given equation, let's suppose this is phi is equal to fx, for this equation itself at various points of x, the slope changes. So when you are talking about slope or tangent for a given curve, you have to define a point where you want to find the slope or tangent. So similarly in this case, I wanted to find the slope of the tangent at point x0, y0, and the value is nothing but f dash x0. This we have learned. So once I have the slope, I can get the equation with this general formula, y minus y0 is equal to m. Instead of m, I'm saying f dash x0, because I'm finding equation of tangent here. Please note, I am finding equation of tangent, so m is equal to f dash x0. Now same thing if I want to do for the normal. For normal, my slope is minus 1 by f dash x0. Why? Because normal is something like this. If this is my slope, this is my normal. So normal is nothing but normal is perpendicular to slope. Correct? And if I know that if two slopes are perpendicular, then m1 into m2 is nothing but minus 1. let m1 be the slope of normal and m2 be the slope of tangent. So if you see here, m1 is nothing but, sorry, it's minus 1 by m2. Correct? Slope of normal is nothing but minus 1 by slope of tangent. Correct? See, slope m of normal into m of tangent is nothing but minus 1 because they are perpendicular. So slope of normal is nothing but minus 1 by slope of tangent, and that is nothing but minus 1 by f dash x naught. So once I have slope of tangent, I can very well find the equation of tangent. Sorry, once I have slope of normal, I can very well find the equation of normal. That is nothing but same thing. Y minus y naught is equal to m. Instead of m, I am saying minus 1 by f dash x naught into x minus x naught. Same thing, if you rewrite, you get this value. It is y minus y naught into f dash x naught plus x minus x naught is equal to 0. This is my slope of equation of normal. Please note, both the equation are different. This guy is my equation of tangent at x naught y naught. This guy is my equation of normal at x naught y naught. See, logically everything is same. The only change here is, in case of tangent my slope is f dash x naught. In case of normal my slope is minus 1 by f dash x naught. Now once I get the slope, I'm using the same formula to derive the equations. We have some special scenarios in case of tangent and normal. First case, when the tangent line is 0, that is tan theta is 0, and second case when the slope of tangent line is pi by 2. So this is, I'll tell you how, this is my slope, let's suppose. So if at this point, if you see, my slope is slope of tangent is equal to 0. So here tan theta is 0 because the angle which this line makes with x-axis is 0. So in this case, for example, this same curve, at this point, if you see, my slope is like this. So at this point, here tan theta is 5. Here my slope is pi by 2. Here my slope is 0. Here my slope is pi by 2. And here my tan theta is tan pi by 2, that is 1 actually. So it is infinite. Tan pi by 2 is infinite because sine 0 by cos 0, sine 0 is 1, cos 0 is 0, so it is infinite. Yeah. So here slope is tan theta is infinite. Correct? Let's take some examples to understand this kind of questions. We have the first question that says we have to find the slope of the tangent. Please note, I have to find the slope of tangent to this curve at x is equal to 4. So if you want to visualize this is a curve, this is the xy axis, and this is some curve actually. And at x is equal to 4, let's suppose this point, I want to find slope of tangent. I know that slope of tangent is nothing but f dash x naught, where x naught is the point where I want to find the slope. Correct? So if my fx is equal to 3x to the power 4 minus 4x, my f dash x will be nothing but 3 into, this will become 4x cube, and this will become, x will become 1. That is 12x cube minus 4. Now instead of x, I'll put 4 because I am interested in fx naught, and here x naught is 4. So this becomes 12 into 4 cube minus 4. That is 12 into 4 cube is 64 minus 4. We solve this, becomes 764. Correct? 768 minus 4, 760. So this is nothing but my slope of tangent, because this is nothing but f dash 4. correct? So my slope of tangent is very easy to find, that is nothing but 764. And to find this I did nothing, I found the value of f dash 4, because my slope of tangent at a point x0 is nothing but f dash x0. Let's take one more example. Here we have to find the slope of tangent to the curve y is equal to is xq minus 3x plus 2 at the point whose x coordinate is 3. Similar question, the only thing is the language is different. Here instead of giving the point, they are saying point whose x coordinate is 3. That is, there is a point, that is 3 comma y is a point, because there is a point xy and x coordinate is 3, so y coordinate is not known. So there is a point 3 comma y, and at that point again we have to find slope of tangent, correct? Same thing here, slope of tangent is nothing but f dash of 3. Why? Because the point is 3 here, x0 is 3 here, correct? At this point we have to find the slope. So first thing, my fx is nothing but x cube minus 3x plus 2. So I'll find f dash x. That will become 3x square minus 3. And then I'll find f dash of 3. That will become 3 into x becomes 3, 3 square minus 3. That is 27 minus 3. And that is nothing but 24. So this is my slope at x is equal to 3 for this curve. Correct. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.